No.
Don't have question. Then, have you encountered any difficult problem solving? How many problems have you solved last week, please?
Let me check. Let me
Yeah.
grab my book. Just review
Yeah.
set A.
Yeah.
I've just done review set A.
How many questions have you solved last week? One, 10, 20? How many?
I will see. Check.
Roughly, not important.
Roughly around, I'd say 15, but there's like A, B, C for some of them.
Okay. Have you encountered any trouble?
No,
Not at all.
no. But with schoolwork, I do have a bit of trouble.
So you want to going to talk about your schoolwork today?
A little bit.
What's that? Can you raise the issue? The mathematics or other subject? Math,
Solving polynomials.
polynomial, polynomial. Yeah,
Yep.
polynomial is what's polynomial? Can you tell me how to write a polynomial?
X,
We use
X
p.
to the power of 3.
Yeah,
Mm.
it's
P
polynomial.
and then,
P for polynomial. Is that notation?
Yep.
Have you studied this notation, which is as a coefficient? So can we put a k here and x to power k? Do you know this notation? 0 to n.
Hang on, I can't see your whiteboard.
You can't say whiteboard. Wow, what? Click here to adjust your count setting. External participants cannot access the whiteboard after meeting because external cloud sharing is disabled in your account. You that allowed me to. Okay. Oh, this something they don't allow me to share the whiteboard for some reason. You
Hmm.
cannot see the whiteboard. Wow.
No.
Let me see. Let's just stop this. Can we share something else? Can we just
Yep.
let's go to this. Do you use a Skype or can you use a Skype if you wish? Can you see my white? Can you share my screen? Can you see my screen? Let's share my screen.
Uh,
I will share. Hang on, I share my screen. One
yep.
moment. Because I don't like their whiteboard. I just use uh, sharing. I share a screen. If I share a screen, okay. If I share screen, can you see my screen now?
Yep.
Oh, super. So I share. Today I use this pad. Okay, I use this pad
Hmm.
to discuss question. Yes. Yeah. Make it larger because we might see more. To make this more effective, I use a dark background. Okay, let's do that. Okay, I write something. It's too small. Let's reduce that to. Okay, that's better. Can you see my writing?
Yep.
Good. Okay, the general form for the polynomial is written as Pn equal to, did you have learned the sigma form? Ck x k.
The teachers mentioned it, but I
Oh,
don't.
not yet, not yet. Okay, I just
Yep.
give you general formula here. This polynomial, okay? What do you
Hmm.
mean the polynomial? If you expand that, give you some idea. So when k equal to say k equal to 0, because this is a from, can you see? K from this number to this number. Can you see? So when k equal to 1, 0, we got C0 x to power 0. And this sigma means the sum C1 x1 plus C2 x2 and so on until Cn x to power of n. So this is when k equal to 1. Can you imagine that? This is where k equal to 1. And this is where k equal to 2. And this is where, guess what? What is k at last term?
K equals n.
That's right. So when you see this sigma, you know this is a sum, okay? Now this general form, this is a general form. Now let's go to special, okay? Special form, special cases. So n is integer, okay? N is integer. Because you mentioned this idea, it's a very important idea. Is integer. You know integer? So integer 0, can you see? 0, 1, 2, so n equal to 0, 1, 2, 3, and then, okay. So special case n equal to 1. So what is special case? P no, can you write it down? What is n equal to 1? Tell me. How many terms?
N minus 1.
No, you have to count from here. Can you see?
2.
2 terms. That's n equal to 1. Can you see? Because k from 0, you just write down. So n.
Oh, n equals 1. Yep.
Yeah, x, and this 0 plus c1. That's it. Okay, x to power 1. Now, can we simplify this one? What is x0? What is power 0? What is x to power 0? Quickly.
1.
Yeah. So that would c0 plus what is the, so that is a c1x. Can you see that? Because x1 is just equal to x, isn't it? Right? So this is a linear equation. Remember that?
Yeah. So what is c?
C is constant. C is coefficient. Coefficient. Now, if you compare with this one, so if we compare the y equal to mx plus b, do you remember this formula for linear equation? Can you see that? Do you know this is a linear function? Yes or no?
Yes.
Do you remember what is the shape looks like?
Straight line.
Yeah. So basically, so when n equal to 1, we got a linear. When n equal to 1, we got the linear equation. Can you see? So that is how I draw this very. Oops, sorry. Yeah, actually, I prefer to use this one. Okay. Yeah, I better use this one. So basically, if I draw a straight line, that would be like this. Okay, you see that? So from now on, I give you some. So you know that the linear function is a special case of polynomial. Does that make sense? So when n equal to 1, when that became, because y is equal to, in this case, p1, can you see? Sorry, this is not 0, this is 1. Okay. Is equal to this formula. Can you see? C0 plus C1x. Alternatively, you can write this as y equal to m plus, sorry, mx plus b. All right. So what is m in terms of c? What is the b? Can you write? Can you participate or you can't? So sorry, this is not interactive. You just tell me what is m in compare with these two equations. What is m?
C.
No, C1. Be careful.
Yeah.
What is b?
C0.
That's right. Do you understand? So therefore, the linear, so this is linear, so this is a linear, I read this conclusion, the linear function is a special case of a polynomial. Poly means many, okay? This means many. Do you know English, the many?
Yep.
Polynomial. When n equal to 0. Does that make sense now?
Yep.
Okay, let's continue if you can follow me. Now let's go to the second case, second special case, when equal to 2. Can you expand? Can you tell me what is this is 2 now? Can you see? As c ck xk and k from 0 to 2. How many terms do we have here? How many terms?
There's 3.
Yes, good. What are they? What? So this k you count k from 0, k equal to 1, and k equal to 2. That's it, okay? The highest. That's you follow this notation, okay? So the first one is C0. Is that right?
Yep.
You can put it here. You can 0 and C1 x1 and what is third one?
C2 x2
square x square. Okay.
Yep.
Does that give you things that equal to C1 plus C1x plus C2x squared? Can you follow me?
Yep.
Now, if you compare with this another familiar equation, we got ax squared plus bx plus c. Do you remember this one? What's that? What do we call this? This is a quadratic function. Can you see? So, what a conclusion can we obtain? So this is a quadratic, quadratic function. You see. So what conclusion can we obtain compared with the first one? So what is the relation between a quadratic equation and a polynomial? Huh? Hello?
Yeah, I'm thinking. So
no, just read this. They were this is our conclusion. Can you see? Can you read it out? A linear function
is a special case of
polynomial when n equal to 1.
0.
No, equal to 1. Sorry.
1.
So what can you see? A quadratic function is a special case. Do you agree? Special case of polynomial when n equal to what? Quickly.
When n equals 2.
Correct. Okay, let's just rewrite. We'll go some backward. Okay, let's consider this. Oh, that's right. I just enlarge this. I enlarge this a little bit. Actually, I prefer use this one. It's easier to draw and write. Okay. So we'll have after that, see, I will do it one by one. So in the third special case, I write it backward, ask you to tell me how to rewrite that polynomial. So basically, what I'm going to do is to, I write this, the third special case. So given y equal to, can you watch carefully, equal to axq bx squared cx and plus d. Can you rewrite this as a polynomial in the sigma form? What can you do?
Sigma c.
Probably. Yeah, go on sigma c, right?
C
sub k, right?
C3 yeah, sub K
X
X.
to the power k, and k from
Yep.
what? From 0
3 K from 0.
to what?
3 C equals 3.
Very good. So that is a cubic equation, which is also polynomial. Can you see that?
Yep.
So all functions, linear, quadratic, can be written as this form. Can you see that? And of course, can you see we use a different notation for we can rewrite this as backward. Can you see that? We can rewrite this as C3 x cubed, C2 x squared, and C1 x and plus C0. Can we do that?
Yep.
We just use different notation. Can you see that? We use different notation, and then reverse it. 0 plus C1. I don't want to write. I write it for better. Can you see? C sub 0 plus C1 x plus C2 x squared and plus C sub 3 and x cubed. All right.
Mm-hmm.
So that is exactly equal to this one. Do you agree? Okay. Now,
Yep.
that is a polynomial idea. Okay, that is a polynomial. Now, second issue, well, I'll give you some background. Second issue is the cubic equation. Is cubic equation. So what is a cubic relation? So we just compare with this quadratic equation. Quadratic equation. We have studied equation for years now. Do you agree?
Mm-hmm.
So cubic equation is this, that is equal to, so that is when I use either things 0 plus C1x plus C2x squared plus C3x cubed equal to 0. Okay.
Mm-hmm.
If you compare with quadratic equation, that is what? It is C0 plus C1x plus C2x squared equal to 0. Or x squared a plus bx plus cx equal to 0.
Mm-hmm.
So you know this quite well. Do you agree? You know this quite well. Can you see that? So the cubic one is very similar to that one, except that they have additional term here. Can you see that? They have additional term here. Let's use this. They got additional term over here. Can you see?
Yep.
Let's rewrite this. They got additional term, but the rest is just a cube. This part is just quadratic. Can you see that?
Yep. Mm-hmm.
So that is a difference between a cubic equation and quadratic equation. Okay. Now, unfortunately, although we know that this is a formula here, I think by now you should be very familiar with that now. The solution for x is negative b minus plus delta. You remember? To a, what is delta? Tell me quickly.
B squared minus 4AC.
Very good, 4AC, okay. But what is x for cubic? No formula, okay? The formula is too complicated, okay? Then there's no cubic formula, or it is too complicated, okay? So in general, we cannot solve the cubic equation, all right? Because we don't have formula. So in general, the formula is too complicated, okay? Too complicated. Okay, but in a special case, we can solve the problem. Special case for the cubic, can you see? For example, there are several special cases we can discuss for the cubic one. You will find in a special case, we can solve that. first case is how about the C2 equal to 0 and C1 equal to 0? What can you write the formula for the cubic equation? Let's just look at what is a cubic. Can you see? So if these two terms equal to 0, then we got this special case that is C0 plus CQ equal to x to power 3. Can you see that? I take, for example, xq minus 27 equal to 0. This is just an example. Can you follow me?
So then x cubed equals 27.
Yes. Now, in this case, do you think you can solve the problem or not?
Yes.
How? Tell me, just tell
add
me.
27. Add 27
you
on
just
both
rearrange
sides.
rearrange that into the other side. Can you see?
Yep.
27. And rewrite 27 as a 3 to power q. Can you see?
Yep.
Can you follow me?
Yep.
Yeah. So 3q equal to 27. Do you agree? Because 3q equal to 3 multiply 3 multiply 3. Can you see that? So do you think you can solve this problem? It's cubic.
Yep.
Yeah, how? Can you solve this one? It's a special case.
If x3 equals 3, if x, wait, is that x squared or cubed?
It's cubed. It's cubed.
X cubed equals 3 cubed. So then x equals 3.
And we just use this rule. Do we use this called a surb? You're gonna surb. Have you had a surb?
Yeah.
So they call just a square, just a root, or we just call the root. Okay.
Yep.
Nth row, nth root. They call the surb. It's old fashioned, but we just call the root. Okay. So in this case, we just argue that if you got this form, that's another formula. We're just equal to itself. Okay. Therefore, C a 3 to cubic and row third rows. You know how do we solve that problem? We just index null. Can you see? Do you remember index null? Yes or no?
Yes.
So you multiply this 1 over 3. That we could to power 1 that equal to 3. Okay. So that I put the index null here. So index null, very important. Okay. Index null. What is the index null related? So you got n to power of a to power n. Check your formula. Did you print out your formula in front of you? Not yet. Please do so.
Yes, I have it.
You added the new formula. Okay.
I've added new formulas.
For formula. Okay. So tell me what is the index null for this one? How do we simplify? If we use
a equals nm. Oh, a and m.
Multiply or plus?
Nm. Multiply.
Multiply. Good. So in this, that's how we use this index null here. So this problem solved. See, but be careful. X could be positive and negative. Can you see? Do you understand? So basically, you have to be careful. The solution is equal to 3 and minus 3. You have considered two possibilities. Does that make sense? We check, okay, which I'm not sure. So in this case, what is this is Q is equal to 27. That's correct, okay? But how about can we use -3?
No.
Cannot.
It would equal -27.
That's right, yeah. So there's only, so therefore, there's only one solution, all right? Let's go to another special case. This one. Another special case for the cubic, okay? Special case 2, okay? So this time, can we net equal to C null equal to 0, okay? And C2 equal to 0. Now, in this case, can we rewrite the cubic equation? There are two terms equal to 0 now.
Yep.
C1 x term plus CQ x cube, right? Can you follow me? Yeah, equal to 0, okay? Let's go to example, okay? Can we say we have the 5x cubed minus 6x equal to 0, for example. Can you see? Now tell me, what is the C1? What is the C2 in this case? C0, C3, sorry. In this equation, what is this two coefficient?
C1 is -6.
Yes.
C3 is 5.
Good. I will ask this basic question again and again, okay? So you would never forget this, all right? Now tell me, how do we solve this equation? Tell me quickly. Shift
So
this
then
side.
we'll move 6x to the other side.
But why don't we factorize first? Can we factorize x? Can you follow me? If I do so, can you follow me? What I have done from here to
Wouldn't
here?
that be -30x?
No. Oh, sorry. We have to we don't put the 5. 5 is not cofactor. Okay, this is wrong. Okay, so do it again. 5 is not cofactor. The factor, can we just factorize x? We factorize x, we have 5x squared minus 6. Can you follow me? Oh, no 6 anymore, just 6. Can you follow me? Okay, do you think, can you solve this problem? What is the possible x if the product equal to 0? What is x1? What is the possible solution to make this equation?
0. Yeah. X1 could be 0.
Yeah. Okay, another possibility is 5x. So there's one option. So one is a possibility. Okay, that is one case. That is one case. There's two case. One is 2 minus 6 equal to 0. Okay. When you see this a multiply b equal to 0, there are two cases. Can you see? So one possibility is a equal to 0. Okay. Another case is b equal to 0. Got it?
Yep.
So based on this idea, we should be able to find another x. Can we solve this equation? What's type of this question? What is
Quadratic.
name? Quadratic. Can we rearrange that one in this form? Can you follow me? I just go very quickly.
Yep.
And the square root uses serve, but be careful to plot. You have, when you do so, you have to edit the minor plus here. Can you see that minor plus here, or equal to minor plus square root 6, 5. All right. And on the other side, you can cancel this one. So I put the index node here. Any important index node here is another thing, is that you have the can you follow me? If you have if a squared to a square equal to what? Please quickly.
A.
Yeah. How about the q? The third.
A.
Yeah. So that is the index node. So this is if you still have trouble, just memorize it, okay? Because you are going to this just like play the music. You have to use this all the time, okay? This is minor key, or there's the chords, okay? You understand? So when you study math, you do memorize something, okay? That saves you time. Now, if you don't memorize, you have to always check the formula, okay? Got it? So you can see that answers the question that in a special case, we can solve the cubic equation. Okay. Now that is how about other issues? That's your turn. I think by this half hour summary, we have know the background. So we have know the background. We know what is a cubic. See. So let's just the summary here. In summary. Okay, what we learn? A polynomial, polynomial of degree. They have used called degree. Okay, a degree n can be written as Okay, polynomial n to the power, this is called the degree, okay? They call the degree, okay? Degree or the rank, if you wish, degree or rank. Can you see that? I prefer use degree, okay? Can be written as this form, sigma form. N is a coefficient, okay? The number, yes, coefficient, okay? They have more than one, it's coefficient. So that is x to power of k, k to k, k from 0 to n, okay? That is summary, okay? In a special case, when n equal to 2 and Pn in a special case became polynomial, can you see? And be written as the polynomial ax squared plus bx plus c. Can you see that? How about n equal to 1? We just going back equal to 1. What is p degree 1?
P1x equals to bx, ax plus
you can
b.
use x plus b, okay? Or you can, doesn't matter, you can use m multiply
mx
b,
plus,
doesn't matter. It's the same thing,
yeah.
okay? Okay. And finally, how about when n, sorry, not the order, right order. What, how about the 4? So when n equal to 3, what we'll have? How many terms do we have? How many terms?
4.
That's right.
Well,
That's C0, C1x, can you see? Plus C2x cubed, x squared. And finally, what is the last term?
C3x cubed.
Very good, 3x cubed. So it doesn't matter. In a textbook, sometimes they give you ax cubed or bx squared plus cx plus d. It's the same thing. Do you understand? The same thing. So that is algebra. You can use any letter to represent something, okay? So, okay, any other question? So in general, Q3 equal to 0 has no simple formula, you see?
So how do you solve a polynomial?
We solved this already. We solved the equation. Can you see? You used to have trouble, you see? So let's write down here. This is a polynomial. And that is the equation, okay? It's different idea, can you see? Polynomial is when, say, this starts from linear equation, okay? Linear equation, this linear equation, can you see? C0 plus C1x, okay? For the equation, you have to use this equal to 0, can you see? Similarly, if you go to the cubic, can you see that? C0 plus C1x plus C2x squared, you have to let that equal to 0, can you see? That is the difference between the polynomial and equation, can you see? That will give you, do you know this sign here? I use this sign. It means therefore, can you see? Therefore, okay, that is a short note, okay? Therefore, we have C0 plus C1x equal to 0. And for this case, we got C0 plus C1x plus C2x squared equal to 0. Or we can say ax squared plus bx plus c equal to 0. Can you see that? So that is equation. Can you see that is this quadratic equation? This is linear equation, okay? And the cubic equation, that is next one. And the cubic equation, this cubic nomial, this third degree, this is third degree polynomial, all right? Cx plus c2x squared plus c3x cubed, all right? But the equation is p3x equal to 0. And that will give us, can you see? C0 plus C1x plus C2x squared plus C sub 3 and x cubed equal to 0. Now, I hope you know what is the equation and what is a polynomial now. Can you see the difference? When you build an equation, you have to let this equal to 0. Can you see that? Got it?
I get it.
Okay. Any other question we can discuss today, or do you want to do some? Now, can you choose a? Can you tell me the problem? Can we just find the problem to solve? Let's just make this. Do you have textbook? Do you have a handout? Do you have? Can you go to textbook to find the question problem solving first? We still have half hour. Can we just do some exercise? So I can send this to you, but you make sure you were start. Okay, this is this. I put the exercise on other side. Okay. Oops, sorry. Put a vertical line here. Okay, let's zoom in. Yes, that's good. Okay, let's do some exercise, please. You want to solve which question? Cubic or quadratic? Which one to solve?
Cubic.
You want to solve the cubic. So we go to special case, okay? We just go to the first side to solve the cubic equation. Now this time I give you something like this. Can you see? Can we just x cubed minus x squared, or I put a number here, 3, okay, plus 6x equal to 0. So this is a typical cubic equation, okay? Now, tell me how to solve this problem. By the way, what is a polynomial corresponding to this equation? What is a polynomial?
P
sub 3, can you see? It's cubic, right?
P sub 3x.
Equal to equal to C0, can you see? Oh, it's a sigma form, okay? Ck x to power k, k from 0 to what?
3.
Good. So C0 equal to what? C0, or just in this case, what is C0 in this case?
0.
Good. How to C1?
6.
C2 is simple now.
-3.
And C3.
1.
Very good. Okay, now it's your turn. How do we solve this problem? Look at it. Any simple algebra, we can simplify this. Can we simplify, reduce it as a quadratic equation? Quadratic equation? Answer this question. Yeah.
We could factorize the first two.
Very good. Factorize, yes. Yes. To factorize, okay? To factorize what? X
squared on the outside. Yep.
Now, what is cofactor? Can you see in this term?
X squared.
Right. X squared, are you sure?
Yep.
No, cofactor. What is cofactor? Be careful. You are almost correct. What is a cofactor? X or X squared? X squared?
X.
No X squared, okay? Understand? You feel X squared can only share by the first two. You see that? So this is not cofactor. I change the color slightly. So this is not cofactor, but this is, all right? So that's why we factorize X. So what can we obtain if we factorize X?
X squared on the outside, like outside the brackets.
Bracket. So what's left for
X
the first
squared.
x
Like
squared?
X squared on the
How about
outside.
second
No,
term?
like no, that's the first one. Like the
Yeah,
first one, X squared.
yeah, x.
Like the one outside the bracket.
Yeah, go on. What is second term? X, if you factorize x.
Just 3x.
Okay, how about third term?
Plus 6.
Plus 6. That's all. Can you see?
Mm-hmm.
So we just go to this form again. The product equal to 0. What is the possibility for A and B? One for scenario A equal to 1,
X
okay?
equals 0
Or
or
B
X
equal to
squared
0.
minus 3x plus 6 equals 0.
Okay, let's solve this one. We actually, can you see, therefore, x equal to 0 is one of solution, okay? Is one of the root, okay? When we say root, it's called a solution, okay? Solution, can you see?
Mm-hmm.
For x. Can you see that? Good for me now. The root, can you see the root? All right. The root, can you see that?
Mm-hmm.
So how about second scenario? If a, how about this term equal to 0? Can you see that? Another says a plus 3x plus 6 equal to 0. Do you agree? Two possibilities. Now it's your turn. Can we solve the x? What is what is the name for this equation?
Quadratic equation.
It's
We can use
quadratic.
the
Can we
quadratic
simplify
formula.
it now? This is quadratic, yeah. Quadratic equation, okay? Okay, alternative that is P2 equal to 0. Can you see that? When you build, when you find just one x, when you have to use this notation for equation, okay? This is a special case when this polynomial equal to 0. Then we got the proper equation. Now, can you solve this one? What is x formula? B plus root delta. Can you see very fast how fast I wrote solve the problem? Can you see?
Yep.
So what is delta? Tell me.
9.
Yeah, 9.
9 minus
Yeah,
24.
yeah, 24. Oh,
Yeah.
that's we have
No
trouble.
solution.
Yeah, no real solution, which is negative what?
Negative
Okay.
15.
Negative 15, which is less than 0. Okay, so therefore no real root. Okay, but I tell you what, they have complex solution. Okay, I give you some idea what is complex number. Okay, however, and delta can be written, delta equal to negative 15 can be written as, can you see that? Can be written as, let me see, is 15, can be written as negative 1 multiply 15. Do you agree? Therefore, square root delta will equal to square root negative 1 multiply 15. Do you agree?
Yep.
And then we can use index law. I use index law now. Can you see if you have a multiply b to the power of n, how do we simplify this? Quickly.
A n b n.
N b n. Okay. And similarly, if you have the square root a b, how can we simplify this?
Square root a square root b.
Multiply dot product. Can you see that? So there's index law you want to write down. So in this way, we got root 15 multiply root negative 1. Can you see that? Can you follow me? And normally people stop here, but I can write this as a square root 15 multiply I. Okay, what is I? Can you guess? What is I? From here to here, what is I?
Negative 1 square root.
Yeah, okay. So that is important. It's called imaginary number. Doesn't matter. That means you can still continue. All right. So if so, what is x? X must equal to negative b plus minus
3.
Yes, you can write down that 2x to a. What is b? Do you remember? Negative 3.
Negative 3. So 3 plus minus
3 plus minus this square root delta, which is 15i divided by 2. Do you agree?
Square root 15 now, right?
Square root, yes. Oh, square root, yeah, we have square root, yeah. Can you see that? Can you
Yep.
follow me? Is that
Hmm.
correct? Or you can
Yep.
write as 3 multiplied 2 multiplies square root 15 divided by 2 and multiply I. Can you see that? So therefore, from here, x2 equal to 3 2 plus and x, what is 3? What is another root? Can you see? What is another root? Quickly.
1.5.
Now minus, can you see? You just follow this one, okay? You choose a positive, positive.
Oh, yeah.
So how many roots altogether?
3.
Yes. So in general, in general, cubic equation has 3 roots, okay? Okay. Do you agree?
Hmm.
If a complex number, if a complex number, just give it a name here. You are going to start a complex number, okay? If complex if complex numbers are included. Does that make sense? That's conclusion. How about cubic? How about quadratic? In general, quadratic equation. How many roots for quadratic? How many?
1.
Now, quadratic. What is quadratic? Ax squared plus bx plus c equal to 0. How many in general?
3.
That's right, because I got 2 here, can you see? Again, if complex number is included, is numbers are included. Okay, this is very brief introduction of what we call a complex number. Can you see that?
Hmm.
Have you heard of that before? No?
Yep.
Yep. So that is complex number. So therefore, that answer your question that the quadratic one, cubic equation have 2. So together, so therefore, what is x1? So all together, you have finally you have tell people, so all together, we have 3 roots. X1 equal to what? 0. Can you follow me?
Hmm.
X2 equal to this 2 number. Can you see? 3 2 plus root 15. I hope you can. What are you going to do after this lesson? Because you can't write. Can you copy this into your notebook? Do you agree?
Hmm.
You spend half hour or so to copy this note into your notebook, exercise book,
Yep.
very carefully,
Hmm.
okay? That is another way you learn new things, all right? We have 10 minutes, so any question?
Nope.
No, well, why don't we find, let's take this 10 minutes to draw the diagram, okay? Draw the
Hmm.
diagram. That probably will help you to in the long run. So there's how to draw another issue here. So we'll go very quickly. I forget the name, but I can put 4 here. How to sketch polynomial, okay?
Hmm.
So I put the x-axis y here, for you to think. Can you see? Can we start from the from linear? Can we start? Let's do something simpler first. Okay, this is x and y. I use y to represent the polynomial. Okay, y equal to polynomial. Polynomial is a function. Can you see?
Mm-hmm.
And this is x. This is 0. Now, can we draw n equal to what is the graph when n equal to 0? When equal to 0?
Just when n equals to 0.
Yeah.
P0, x0.
Yeah.
Just nothing, right?
That's a constant.
Yeah.
The constant. Can you see? C no. Can you see? Can we draw that? Okay, just it could be negative, could be positive, because this is say no. Can you see that?
Mm-hmm.
That in this case, we assume the say no is 0. Okay, that is n equal to 1, n equal to 0. Can you see that? Say that is n equal to 0. Can you follow me?
Mm.
Oh, change the color. Why? I just draw this straight line close to that one. It could be negative, could be positive. Okay,
Mm-hmm.
that is horizontal line. Can you see? Now think of how about one n equal to 1? How about n equal to 1?
Uh, Quadratic.
No, n equal to 1. Think about it. Now try again.
A diagonal line.
Not diagonal. No, it's a straight line. You can do it 1 by 1. So we got n equal to 0. That is a 1. And we got if we got a quadratic is different color. It's a straight line. Can you see that?
Mm-hmm.
We write it down. So that is n equal to 1. Can you see?
Mm-hmm.
Y is equal to nx plus b. Do you agree?
Yep.
So that is 1. And this is y equal to a constant. Can you see?
Mm-hmm.
How about n equal to 2?
An S?
No, no,
Well,
no.
not an S. Like a curved line that
Parabola.
just roughly.
Parabola. I because parabola.
Yep.
You have to get familiar with term. Can you see?
Like a semicircle.
Not a semicircle. No,
Like not completely semicircle. Like
not
it's a
like
bit
this. Can you
oval.
see? Can you see that?
Yeah. I don't know how to describe that.
They got it's called. That is a proper name. Can you see
Parabola.
parabola? Can you see? See this? Yeah, called parabola. Call it parabola. Okay. So that is equal to y equal to ax squared plus bx plus c. Can you see that? That is n equal to 2 curve. So what is this point? What do we call
The
this?
turning point.
The turning point. Any other?
Line of symmetry.
Flex is it has proper name. This is line symmetry. Yes, you're good. That's good. But this is just one possibility. Okay. A quadratical, if you go to the n equal to quadratical, that diagram, don't mix it with that other side. Okay. So if you go to quadratic, in general, quadratic have many things. You see. So this is one of them. So quadratic can we start a simple, oops. Can we start from simple quadratic? So this is one of them. Can you see is symmetric to the center? Can you see that?
Mm-hmm.
Or it could be like this, as we just learned. Okay.
Mm-hmm.
How about this one? Is that possible?
Yes.
Everything is possible. Can you see? Okay. However, in this case, can we call this? I put a proper name here. Can I call this is? This is A, this is B, this is C, this is D. Okay. Now, what is the delta in this case? What in this case? Where's delta? Delta is not smaller than 0 or larger than 0. This is X, sorry. This is Y. What is delta? Is delta positive? How about this one? How about the delta here? How about,
Negative,
yeah, negative, yeah. How about this delta? How about this delta?
positive,
That's positive, yeah. So I write down here. So this delta, can you see delta is a positive. Okay, how about delta over here in this particular?
negative.
No, zero.
Oh, because it's in the center, yes.
Equal delta equal to the, can you see? So in this
Yep.
case, how many rows? We have two identical solutions, okay? In this case, we have two real rows, can you see? In this case, we have no real rows. Can you follow me?
Yep.
But
And so D also is small. In D,
yeah,
delta
how
is
about
also
D?
smaller than 0.
Smaller there, yeah. How in case
No
D, how
real
many
roots.
two rows? Can you see? In D, the delta is
Oh, two rule.
larger than 0. Two rows, can you see? How do I know? I extend that, can you see? I extend that, we see the intercept of X. Can you see? That is 2. Can you see that? No real row means doesn't mean no root. Can you follow me? No
Yep.
real root doesn't mean there's no root. Okay, they still have two complex solution. Comp next row. Comp next row. That got it? The number is still the maximum solution is still 2. I emphasize this 2. They still have two solutions. All right. Although they have no real roots. Can you see?
Yep.
Everything to do with these two here. Okay. That is so you're getting tired after 1 hour? Yes.
Little bit, yeah.
Okay, I'm going to finish this very soon. Now, if you please, can you see? I write this. Oh, you put a copy to 3 pages. Do you understand? Okay.
Yep.
I send this picture
Okay.
to you, and you copy them into a notebook, so you learn something new. Okay.
Yep.
And if you have further question, I will email some problem solving. Okay, after this for next week. Okay, please do keep doing the problem solving in your Access book. Okay, 2 homework. One is copy this note into your books. Okay, and then I will send to you perhaps 10 or 20 questions to you. All right.
Yep.
So if you can keep doing that, then your math will be okay. All right. But if you stop doing exercise, like if you stop play some musical instrument, your skill will drops. Okay. Okay, I will stop here. I will save 1 moment. I will save that before we go save us. This I prefer to use this writing better than their whiteboard. I think they were going to something wrong with my plan or something. I don't care. As students. So I put this as your lesson note. Okay, I write down the lesson note. Lesson note. And that's the date 20241109. Okay. On polynomial. Okay, we have discussed a lot of things. Okay, you're going to, by writing this note, copy the note to your notebook, you can review what we have learned. Okay. Hello, can you hear me?
Yes. Copy them into my notebook.
Yeah, and we'll send some example. Can you see? Can you see this
Yep.
beautiful note? Okay, I hope
Yep.
you will write beautifully in your notebook as well. I keep this figure as well. Okay, every lesson, every online
Hmm.
lesson, I will end up with this note for you. Okay,
Hmm.
okay. Good luck.
All right. Thank you.
See you next time.
See you next time.
Goodbye.
Bye.